records. Okay, let me just share the screen. The assignments we're going to be doing are right here. So you can see this C5102 is in the Google Classroom. It's posted over there. Yeah. And well, is solving trigonometric equations. Looks scary, but it's not that bad. It's easy, right? So because we are going to put together two things, right? Let me just show you here. For instance, if I asked you, okay, cosine of x equals 1/2. So what is the x value? Correct? So well, what angle gives me 1/2 for the cosine? You remember this one, the formula booklet. You remember the table we did for the unit circle, correct? So you can see here, table with numbers. And then you see, okay, we need cosine of 1/2, so we look the 1/2 in the values for cosine. Here is the 1/2, and it's pi over 3 or 60 degrees. Of course, there are more 1/2s if you go to the right. There is another 1/2 right here, and it's 5 pi over 3. So this is the way we solve trigonometric equations. In case the angle or the value is different, we use the calculator, correct? So I don't know if they tell me, okay, what is the cosine of x equals 0.3? That number is difficult. Well, okay. So what we can do is very simple. Let me just share the calculator with you, the screen one, this one. So we put a calculator, and then this is okay. Is 0.3, is 0.3, right? But we have to use the inverse function. So we take trig sine, or well, cosine in this case, trig cosine of 0.3, right? And we press enter, and we get the value in radians. If we want the value in degrees, remember to go to the home page, settings, document settings, change the radians by degrees, okay. Then go to current, yeah, number 4, and then you repeat the procedure. You go up, press enter, escape, press enter, and then you get 72.54 degrees. So it's the way we solve trigonometric equations. So it's very simple, really, okay? So if we have values like 1/2, the square root of 3 over 2, or those ones in the unit circle table, we use it. If not, we use the calculator. So it's very simple. Now, it's like we are going to make a shake. If you remember, for instance, x minus 2 equals 2x plus 1. Let me just stop here sharing, and then you have this equation, right? We solve this equation, correct? For instance, let me just put here 1/2. This is x equals 60 degrees, correct? Or pi over 3. Okay, now this is the new equation I want to solve. Everybody knows this equation. What is the solution? This is, well, we subtract x both sides, right? We cancel. We have -2 equals x plus 1. And then we subtract 1, and we get x equals -3, correct? Any problem solving this? Any problem solving this one? What I'm going to do now is like a shake. I'm going to put this in a blender, right? And I'm going to produce equations like this. Cosine x minus 2 equals 2x plus 1, or 2 cosine x plus 1. So we're going to put this together in a single thing, and we're going to solve algebraically and then with the unit circle. So we're going to do 2 steps to solve this kind of equations, but it's just the mixture of something trigonometry with algebra, okay? And the same, we can solve linear, we can solve quadratics. Okay, let's go to the assignment. You see the first example. So I have here this one. And then you can see equation A, this one, right? Equation A. So you have 4 sine of theta minus 1 equals 2 sine of theta plus 1. Looks scary, right? No, it's not scary, really. So the first thing I'm going to visualize is that you have sine here, so we can change that for die sign by an x. Minus 1 equals 2x plus 1. So we visualize this in our brains, that the sine x is a variable, sine theta is a variable, so we change by an x. And then this is something that an 8th grader can solve easily. We solve this equation. So we subtract 2 here, cancel 2x minus 1 equals 1. And then you add 1 here, you add 1 here, cancel here, you have 2x equals 2. And then you have x equals 1, correct? Any problem with that? No, it's very easy. It's algebra 1. Then, but you remember, okay, I changed the sine x by this x. So I'm going to return this sine x or sine theta. Sine theta equals 1. Okay, now, what angle gives me 1 if I apply sine? Okay, here comes my unit unit circle table. So I have to look at 1 in the sine, you see, is pi over 2. For the 1 is pi over 2. So theta is pi over 2. And well, if I continue, I see another one right here is 5 pi, no, right here, another one I have here, let me see, 1, and then the other one right here is 3 pi over 2, comma 3 pi over 2, correct? So according with my table, I have 2 solutions. But remember, theta could be any angle. So this is not going to be the only solution, correct? So let me just get this graph. You have here the sine. Remember, this is pretty much the graph of sine. And then you want the line 1. It's a line like this one. Let me just put this a little bit top, right? So how many times the sine intersects the 1? Well, many to the right and many to the left. So this repeats every 2 pi, correct? Every 2 pi, you intersect the 1. So I'm going to take the first one, pi over 2, right? And then this is okay. So if the solution is pi over 2, the next one is pi over 2 plus 2 pi, pi over 2 plus 4 pi, or twice this one, 2 pi's. Then pi over 2, 6 pi of 3, 2 pi's, 3 times 2, 6, and so on. And to the left is pi over 2 minus 2 pi, correct? Then minus 4 pi, and so on. So every time you cross with the graph, the line, that is going to be a solution. So this is going to be plus or minus, because I do plus and I do minus, 2 pi, correct? So the entire set of solutions for these equations, sine theta equals 1, is going to be pi over 2 plus many 2 pi's, in this case, n 2 pi's, to the right and to the left. Okay? So this is going to be the way we are going to solve this equation. So again, let me just summarize this one. You receive an equation with sines and cosines, and you watch and you read this one. 4 times this minus 1 equals 2 times the same thing plus 1. Looks like a linear equation. So you visualize the sign as an x. Then you have this equation, and then you solve the equation for x. Then you return the x as sine. Okay, sine theta equals 1. And then we have to find for how many angles the sine is 1. Well, if we use the graph of the function, we can see that for many angles, beginning at pi over 2, every 2 pi, they repeat because this is periodic. So the solutions are many, many. If the domain is restricted, then we take as many as they fit the domain. Okie dokie. Questions at this point? It's pretty much clear. This part has no problem. It's a linear equation. Possibly this is the difficult one because, well, solve trigonometric functions, yeah, could be annoying, mainly when you have no restriction in the angle, correct? Is any angle, the angle could be any number on the number line. So in that case, you may have many solutions as this one right here. Okay. Let me just go to the next problem. With the practice, we are going to be mastering this. So, screen again. Now I have this one. 2 cosine theta minus 1 equals 0. 2 cosine theta minus 1 equals 0. Okay. Well, this is the question on my board. 2 cosine theta minus 1, 0. Okay. This is my variable. This is a number. This is a number. So this looks like 2x minus 1 equals 0. I need to find the x. Well, that's easy. Plus 1 divided by 2. So x equals 1/2, correct? Algebra 1, easy. But who's the x? Well, I visualize the x as the cosine, you see? So really, I have cosine of theta equals 1/2, correct? Okay. What values intersect 1/2? Okay, let me see. So the cosine is something like this, right? And something like this in this direction. And the 1/2 is like right here. So it crossed many, many, many times, correct? So you have many solutions. Cosine of the angle equals 1/2 happens for many angles. So I'm going to find this and this, correct? These two. Okay, let's see. What values in the unit circle give me 1/2? So, okay, let's see. I go to the unit circle right here. Oh. Right here, yeah. Let's see now, not very clear. Okay, it's kind of blurry, sorry.
60 over pi over 3.
Okay. 1/2, cosine of 1/2 is right here. You see? Pi over 3. And then the other 1/2 is 5 pi over 3. So I have pi over 3, 5 pi over 3. This table is very important for you. Just keep it next to you, correct? Okay. Now, this is going to repeat pi, and this is going to repeat again 2 pi. Then the same, this minus 2 pi, right? And this one minus 2 pi right here, correct? This one right here minus 2 pi. So my solution is going to be simple. Theta is pi over 3 plus or minus 2 pi n times. Could be 1, 2, 3, 4, 5, any times. Or 5 pi over 3 plus minus 2 pi n. So these are going to be all the solutions for this equation because theta, yes, is open interval. It's all the real numbers. So I don't have a domain that this is restricted. So because this is in the number line, This number line goes to positive infinity to negative infinity, so the intersection happens many times. Okay? A ver, everybody's catching the idea?
Kind of.
Okay. Let me just move to another problem, easy like this. Right here. We have problem Z. Okay? You see problem Z over there? Yeah. Not a big deal. So it's going to be 3 times the parenthesis tangent of theta minus 2 equals 2 tangent of theta minus 7. Okay, so let me just display my board. Here is the equation. Okay, wow. Looks that it's going to kill somebody, right? But don't worry. Tangent of theta is the same thing. So I'm going to visualize my variable tangent theta as an x. So I'm going to have 3x minus 2 equals 2x minus 7. Now, this is something everybody knows how to solve. Everybody solves this linear equation. The only have to do is break the parentheses, combine like terms, and solve. So this is going to be 3x minus 6. Don't forget to multiply both. You multiply just the first one, you mess up. 2x minus 7. Then I'm going to combine all the x's, so I subtract 2 and I add 6. So plus 6 minus 2 minus 2, only algebra 1, and this is x equals negative 1, correct? This cancels, negative 7 plus 6, negative 1, 3 minus 2, 1. Okay, bueno, now, this is really tangent of theta equals negative 1, correct? Okay, now I need to find for what angle the tangent is negative 1. Okay, I have to go back to my table right here, right? Here is my table, and I'm going to look the tangent here. This is 1, negative 1 is right here, so is 3 pi over 4. You see? Okay, theta is 3 pi over 4. Now, there is another negative 1. Yes, there is a negative 1 in 7 pi over 4. Yeah? 7 pi over 4. So I annotated both angles. Equals also this one. Now, let's see. The tangent function, remember the graph of the tangent? This is the graph of the tangent, remember?
Yeah.
The tangent repeats every pi, not every 2 pi. So you see this branch, this branch, this branch is the same, and they are separated by pi. So if you put here a negative 1 intersecting, you repeat every pi. So you have plus minus pi n plus minus pi n, correct? Everybody? So again, let me just review this problem again. I received this equation, scary equation, but I see this one and this one is a variable and they are the same. So I'm going to change this by the same x. So this equation that is scary became this easy one that is a linear. I solve my linear, I find that the x has to be 1. So the x has to be tangent. So I replace the x by tangent. And then I tangent negative 1. Now I go to my unit circle and then I check for what angles tangent is negative 1. When I find the values, I remember that the tangent repeats every pi, not every 2 pi. and then I just put plus minus n pi. N could be 1, 2, 3, 4, 5, any number, integer, same here. So these are going to be my solutions. Possibly one of these could be in this one, I don't know, but it's possible. For instance, 3 pi over 4 plus pi. I'm going to do my fractions. 3 pi over 4 plus 4 pi over 4. Use the common denominator. This is 7 pi over 4. This is exactly this one. So this set right here is contained right here. So I don't have really to consider this one, only the first one. So these problems require some skills with the graphs of the trigonometric functions, okay?
I have a question.
Yes, sir.
How come you added? Wait, I can't see. You added 3 pi over 4 plus 4 pi over 4.
This one?
Yeah.
Oh, because, véanlo así, this is 3/4 plus 1. 3/4 plus 1.
Oh, why did you add it? Oh, wait, why do you add it plus 1?
Because this one, so this repeat every pi. So is this plus pi is another solution. Plus 2 pi, plus 3 pi, plus 4 pi, and so on. So let me I just took the first one. Let me see what happened in the first pi. 3/4 pi plus pi is 7 pi over 4. This same angle, you see?
Mm-hmm.
So this set is contained in the previous one. So I
So
don't
they're
have
the
to
same
consider
thing.
this one, right?
Oh, okay.
This is right here, okay?
Get
It's
it.
repeated. If you repeat it, it's no problem, but if you cancel this second solution, that is going to show that you master this topic, okay? Okay, any question till you arrive to this solution? It's very simple, right? Okay. Let's go and solve the next problem. So let me share screen right here. Now this one, okay. You have now 3 sine of the angle theta minus the square root of 3 equals sine of theta. Oops. Okay, that's my thing. Okay, again, I see sine theta here and sine theta here. So I'm going to cover this by something friendly, 3x. 3x minus the square root of 3 equals x, correct? Now, everybody knows how to solve that one. I'm going to move this to the other side. So 3x minus 1 is 2x minus the square root of 3 equals 0. You move this to the right. 2x equals the square root of 3. And then you divide x equals the square root of 3 over 2. Okay, this equation is really sine theta equals this. So it's really sine theta equals the square root of 3 over 2. Okay, now, for what values this is the square root of 3 over 2? Okay, let's see my table again. Correct? The square root of 3 over 2 for the sine is right here. It's pi over 3. So theta equals pi over 3. And also, let me see, square root of 3 over 2 is like this way. Is right here. You see? 2 pi over 3. So it's 2 pi over 3. You see? So those are the two angles, the two solutions in my unit table. So what I have to do now? Well, the sine repeat every 2 pi. So these are going to repeat every 2 pi. So you put plus minus 2 pi n. Okay? So every 2 pi to the right and any 2 pi to the left, that's the plus minus is 4. You repeat this value, square root of 3 over 2. Remember, there is no restriction under the angle, so could be any number on the number line. So these are the numbers on the number line that make the sign of theta square root of 3 over 2. Okie dokie. Yep. One more. From the next two, E or F, which one would you like to solve? E or F? All of them are easy.
They're the same thing, basically.
They're the same thing. Some linear problems, right? Linear problems. What do you think?
F.
F? Okay. 3 cosecant of theta plus 5 equals cosecant theta minus plus 9. Okay. Let me just stop, go to my screen. That is my screen. 3 cosecant theta plus 5 equals. Okay, again. This is x, so I'm not going really to cover with x. I know that 3 cosecants minus 1 cosecant are really 2 cosecants of theta plus 5 equals 9, correct? And then I subtract 9, so I have 2 cosecant theta equals 9 minus 5 is 4, correct? And then what you do with the 2 at the front? Well, you divide by 2, so you have cosecant theta equals 2, correct? Well, now, for what values the cosecant is 2? Okay, let me see my table right here, okay? So here is the cosecant, and here is a 2, you see? Is pi over 6. Cosecant of the angle equals 2 for pi over 6. Now let me see if there is another 2, is right here, you see? So it's 5 pi over 6. So theta is pi over 6, and is 5 pi over 6, correct? So it's what my unit circle says. Okay, yeah. Then what I have to do, just know that the cosine or the cosecant, this one, the cosecant repeats every 2 pi, so is 2 pi n plus minus 2 pi n. Here are my solutions. Okay? Pretty easy, right? Obviously, you need this. You need this, or you're going to get stuck.
Is that
So
on the
you don't
Google
have
Classroom?
it. You don't have it?
Is it on the Google Classroom?
Uh-huh.
Oh, it's that?
Ah,
Oh, I
well,
have that.
Well, I'm going to upload it in the Google Classroom again.
Thank you,
Yeah.
Antonio.
Yeah.
No problem.
Technically, I gave you a copy a long time ago of this one, right? But
In the
well,
beginning of the year, yeah.
at the beginning of the year, long time ago, yeah. Okay. What is the next portion? Okay. Well, what is the next equation you solve after the linears? You learn to solve after the linears. What is the next equation you solve? When you learn to solve all the linears, what is the next equation you learned?
Quadratic?
Correcto, quadratics. So x squared minus 3x plus, que sería, o minus 6, for instance. No. Minus 3 over minus x plus 5, for instance. Minus 5 equals 0. You remember how to solve that one?
Yeah.
You use the quadratic formula, or you factor, correct? So if you factor, you have x minus and x plus, correct? What numbers are those? Two numbers you multiply, you get up. Oh, well, let me see.
X minus 5, x plus 1.
Este debería ser 6. Let me just
No.
change this for 6. 6
Seven.
is 2
3 and 2.
plus 2 and negative 3, correct?
Yeah.
Yep. And then, well, you solve this one. This is x equals negative 2 and x equals positive 3. Any problem with that? No? You made 100 in this in that class. So you have no problem solving quadratics. Why do we have to do this? Well, because now our problems are going to be like this. Oh. Now you are going to have the thing. You are going to have the thing with the square. Or you have a square function. You see a square. No, it's easy. Have you any problem with this? No. So you're not going to have any problem with the other one because it's the same. Okay. Vamos a hacer dos. Let's do two of them. So give something for tomorrow or Thursday. And we're going to fix that. If tomorrow or Thursday. So I have, let me see. Let me just begin with the easy one. Tangent square of theta minus 3 equals 0. Okay, let me just begin with that one. Okay, tangent square. Remember that this tangent square theta is really tangent of theta, everything squared, minus 3 equals 0. Now, let's change this by a familiar x. X squared minus 3 equals 0. Okay, now, is this difficult to solve? No, this is very easy to solve. So this is x squared equals 3. And then you square root, you have x equals positive and negative square root of 3. So you really have two values. Let me just write it explicitly. X square root of 3 and x equals negative square root of 3. Now, what is the situation here? She says, well, the situation here is the x is tangent really. So I'm going to write tangent of theta equals square root of 3. Tangent of theta equals negative square root of 3. So these are the real equations I have to solve. Okay, for what angle the tangent is square root of 3? Well, again, my table here. You see? The square root of 3 tangent, square root of 3 tangent is pi over 3. Okay. Theta equals pi over 3. And what theta is this one? Negative square root of 3. Okay, this is a square root of 3. Here is the negative square root of 3, you see, for tangent. 2 pi over 3. 2 pi over 3. Okay. Well, now, what I have to do next is very simple. I know this repeats every 2 pi, so I'm going to put pi over 3 plus n pi. Tangent repeats every pi, and this is going to be 2 pi over 3 plus minus n pi. Correct? So here are my solutions to my problem. Okay, again, horrible equation in trigonometric notation. Okay, tangent square is tangent square theta is tangent of theta, everything squared, minus this. I change this by an x. Then I have this quadratic that is easy to solve. I have two solutions. Then I return the tangent. Tangent of theta equals square root of 3. Tangent of theta equals negative square root of 3. And I look in my table, right, in my unit circle table, for what values of the angle tangent is square root of 3. It's right here. So it's pi over 3 and 2 pi over 3. Then I know that the tangent repeats every pi back and forth. So I just put plus minus n pi, 1 pi, 2 pi, 3 pi, 4 pi, and so on for these two angles. And that's my solution. Remember, there is no restriction of my theta. So theta is on real line in the number line. So goes positive infinity to negative infinity. So you may have many solutions as you see here. Okay. Questions here? No? Have the best students, I see. Bueno, let's do now the last one for today. That is the same easy. I'm going to do now this one. This is, oh my God. 2 sine square of theta plus sine theta minus 1 equals 0. Okay. Let's just stop sharing. That's my equation. Okay. I read my equation. I have here sine theta, sine square, and sine. This is the same variable. So I'm going to do my trick. 2x squared plus x minus 1 equals 0. So I have to solve this quadratic for x. Oh my gosh. Let's see if we can factor something. What numbers I put right here? Well, possibly one is positive and one is negative, but I don't know. So what do you think? Positive, negative? What numbers you can fit over there in that parenthesis?
1 and 1. I don't know.
1 and 2?
1 and 1.
1
1 and 1?
Yeah.
1 and 1? Well, let's see. 2x times x, 2x squared. 2x times 1, 2. Minus 1, 1. Negative 1 plus positive 1, 1. Okay. You see here the point is all quadratics and you solve quadratics, so no problem. Okay. Now, this times this 0 means 2x minus 1, 0, and x plus 1, 0. One of them has to be the 0. So what is the solution for the first problem? 1/2, and the x is, let me just put it here together. Let me just put it in this way. Let me see. Yes. So 2x minus 1, 0, and x plus 1, 0. So you have x equals 1/2, and here x equals negative 1. Negative 1, correct? Well, but who's the x? The x is sine, correct? You are replacing the sine by x, so you have to return the sine. Sine theta, 1/2, sine theta, negative 1. Okay. For what values of the angle you have 1/2? Okay. Let's go back to my unit table, my unit circle table. So sine of the angle equals 1/2 is pi over 6. So I have here theta equals pi over 6, right? And the other angle is, okay, 1/2 is also for 5 pi over 6. 5 pi over 6. And for what angles sine is negative 1? Okay, let me see. Negative 1 is right here, is pi. And that's it. It's just pi here. Let's see, yeah. Okay, so
Wait, for
theta
pi?
equals pi. Yeah, it's right here, no?
I thought it was
A
3
negative
pi
1.
over 2.
Entonces 3 pi over 2. You're right. 3 pi over 2. There is. And there is not another, there is no another negative 1, correct? Okay. So these are my angles, correct? So what is my whole solution? Well, my whole solution only is plus minus 2 pi n, plus minus 2 pi n, and plus minus 2 pi n. Why? Because sine repeats every 2 pi. Now you're master solving trigonometric equations, linears and quadratics, okay? Okie dokie.
Yes.
Questions? No questions? Piece of cake?
Yes.
Well, the homework, the grade for this week. So if you go to the Google Classroom, let me see where is the Google Classroom. Yeah, share screen. Right here. Okay, right here. You see the Google Classroom? The window?
Yes.
It's right here. 5102. So here is the assignment I have. Let me just put it again in case you don't see that. So you see here the Google Classroom. This is the entry for today. Here is the assignment whose problems we have been solving. This is your homework. Okay? So you can begin. Now, question. I guess I'm going to need possibly another class to solve this one. So you want class on Thursday or Friday?
When is it due?
Pues the idea is to do this weekend. If you can turn it on Friday, excellent. So see you on Thursday,
Yep.
okay? And I give you free tomorrow to don't stress you too much. Or you want class tomorrow? I give you class tomorrow, no problem. Okay, bueno. Then on Thursday?
Yes.
Okay, Thursday. I'm going to send a reminder Thursday is, we are going to close this portion, okay?
Mm.
Okie dokie. Well,